spherical shell, isn't it? No, outside we finished. Inside we didn't finish, isn't it? P outside. Huh? Yeah.
Yes, sir.
Can I hear all of you, boys? Hello?
Yes, sir, we can hear.
Yes, sir.
Sound is clear?
Yes, sir.
Can you continue a little more? Is there in that? Yesterday I did field inside, outside the shell. Okay. Can you write down number 2? Field case 2 field inside the shell, please. Case 2 is field inside the shell. You cannot see this one on the screen? Huh? Textbook. I cannot push it there. I can display the screen there. How to do this one? No, I can do this. Can I, this textbook on the board, yeah. But I have to discontinue BenQ then, huh? I have to put screen mirror, huh? What is the number? 83. This one. 83. The share screen or eh? Remember this one I did it before. They can also see this one or hello? Can you see the screen? Hello? Can you see that? All of you?
Yes, sir.
Okay. Field inside the shell heading, please. Case 2 is field inside the shell. Can you draw this diagram for me? Second diagram I need it, please. That is the spherical shell is inside, okay? Yeah, draw it. Oh, can you check the room number? How many, what is the room number here? No, outside only, outside only. 182. You will be shifting to the other classes tomorrow onwards. I hope so. Okay? Then you have to find the number of the board. Okay, what is the number of the board? Here you can see the spherical shell is inside, you know. Can you see that Gaussian surface is inside? Diagram one? Okay. Head down. Choose a Gaussian surface. Choose a Gaussian surface. Of radius small r. Choose a Gaussian surface of radius small r, small letter r, okay? So that the point P lies on it. So that the point P lies on it. So the steps are similar to that. So I can cut short fast. Phi, you know, flux is equal to, write down flux is equal to E into 4 pi r squared, you know. Question number 1. Flux is equal to E into 4 pi r squared. Question number 1. Normally, you know, area. Delta E into delta S is the formula. E into delta S is the area, you know, that area of the sphere is that. Flux of the question. Then according to Gauss's law, flux same as before, okay? Flux is equal to Q by epsilon naught. Question number 2. Same equation will come, okay? Same equation will come. Can you understand, all of you, gentlemen?
Yes, sir.
Hello? From 1 and 2, you can write E into 4 pi r squared is equal to Q by epsilon naught. Write down from 1 and 2. E into 4 pi r squared is equal to Q by epsilon naught. Therefore, E is equal to same formula, Q by 4 pi epsilon 0 r squared. But there is no charge inside the shell, you know it? Charge is always on the surface of the shell. You took the point inside. So Q is equal to 0. Next step. But Q is equal, but Q is equal to 0. But Q is equal to 0. Therefore, E is equal to 0. There is no electric field inside the shell, okay? Therefore, E is equal to what? 0. Clear? All of you clear this one? chapter is over. Okay, some extra questions are there that mom will teach you. Okay, so I'll go to the numericals now. Okay, so that it is. But before that, I want to write all the summarize the formulas. All of you write the formula, please. First formula, write down. Q is equal to NE. I hope you know that formula. Q is equal to what? NE. Second one, F is equal to. Can you remember the formula? 1 by what? Remember or not? Q1, Q2 by R
Yes, sir.
squared. This is the second formula. F is equal to 1 by 4 pi epsilon 0 Q1, Q2 by R squared. Do you know the value 1 by 4 pi epsilon? Did she tell the class? 1 by 4 pi epsilon 0 value, you know it? Okay. Write down. Where
9 into 10 raised to minus 9.
1 by 4 pi epsilon 0 is equal to 9 into 10 raised to 9. Nm squared C minus 2. 9 into 10 raised to 9. Nm squared C minus 2. Finish. Third formula. Third formula, I want the electric field formula. Place is equal to 1 by 4 pi epsilon 0 Q by what? R squared. That is the third formula. Fourth formula is, I think then Gauss's law, I think, yeah. Gauss's law. Flux is equal to Q by epsilon 0. Are you writing it, all of you? Fifth formula, y is equal to, I want this formula also, E into delta S into cos theta place. Flux is equal to E into delta S into cos theta. Sixth formula is electric field due to long wire, you know, yesterday I did it, isn't it? Electric field due to long wire. Oh, what is formula yesterday I did it? Can you remember? E is equal to something like, oh, what is formula? Long wire, yesterday I taught you. Long, infinitely long wire, of it and find out, please. Lambda by something is there. I told you to learn it. You never learned it, Mr. O? The electric field due to a long wire. Infinitely long wire.
E is R by 2 epsilon.
Can you locate it? Is there? Yesterday, did you write the notes? What is the formula for long wire? Application. If you don't learn it, what is the problem, man? Oh, you don't have the notes on that or not? Then where is the notes, yesterday's notes? There. Is there or not? Where is it? Huh? Yesterday you were absent? Where is the notes? You never write? Huh? I'm slow, sir. Slow. But I'm here to help you. You wrote it or yesterday's notes are with you. Mm-hmm. Okay. One. Electric field due to thin sheet. What is formula for thin sheet? Yes, Mr. A straight, infinitely long wire. Yes, what is formula for thin wire, Mr.? Thin sheet. Sigma by 2 epsilon. Don't know anything on this? This formula you know it or not? Yesterday I gave the notes, man. Did you write or not? Laptop, how do you write? Type it? I am giving time to write it in the paper room. If you want to learn like that. 12th standard is not like that, please. Not like 11. I gave you enough time. Everybody is writing and learning. You have to maintain a book also. Okay. Eighth one. Eighth one. Electric field due to a shell. Shell or there is a shell or something? What you wrote before? Shell. Electric field due to spherical shell. What is formula ohm? E is equal to sigma. Something is there, isn't it? What is that? Capital R squared by epsilon naught. No? Yeah, full formula I need it. Sigma capital R squared. Yes. Now go to the exercise now, please, all of you. Oh, please write and learn, please. Write it in the notebook. Otherwise, it is very difficult, Om. Look at the formula, etc. It's very difficult. If you have written notes, you can just turn back and find out. All of you write exercises. Write down page number 46. All of you write page number 46. Page number 46, 1.1. Oh, tell me one of your boys name in the class. Remote learning. Huh? Abhishek is here? Mr. Abhishek,
Sir, I'm here.
12C.
Yes, sir, I'm here, sir.
Abhishek is bunging, huh? Okay, I'll report.
Sir, can't
Another
you hear
boy's
me?
name? Another boy's Mr. Huh?
Sir, I'm here.
Mohammed Rayan is here. Abhishek is a bunger. Mohammed Rayan is a bunger. Okay, Abhishek, Mohammed Rayan. Another name? Hashim. Mohammed? Mohammed Hashim is here. Everyone is bunging, huh?
Sir,
Another
the
name?
rectangle
Your
start.
12C is a bunger, huh? Another name? Huh? Rashid Biju is here. Rashid Viju?
Yes, sir. I say you calling me.
Eh? What's his name? Musamil is here?
Sir, can you hear me? Sir,
They are present and running away. Rohit is here? Ken? Can you hear me? My sound is here. Okay, first question. Om, read the question. Read the question, man.
What is the force between two small charged spheres having charges of 2 into 10 raised to minus 7 coulombs and 3 into 10 raised to minus 7 coulombs placed 30 centimeters apart in air?
Yes. How to do the which formula will you work? Tell me. First formula. Can you write the formula, please? F is equal to, please write down the formula. Can you hear my sound? Hello, can you hear me? So then. Write down the formula. F is equal to, that's 1.1, right? Then you write the formula. F is equal to
sir, can you hear me?
1 by 4 pi. Formula I gave you, no? Q1, Q2 by what?
Sir, can you hear me?
R square.
Then I put the values. 1 by 4 pi epsilon, so I can take it as 9. Remember, 9 into 10 raised to 9 should be in the numerator, not in the denominator, okay? Okay, please remember that. Into
Sir, can you
Q1 is
hear
how
us?
much? 2 into 10 raised to minus 7 into
Hello.
3 into 10 raised to. Hmm? Oh, they're talking, huh?
Yes, sir.
Okay. They're alive, huh? They're good boys. Huh. Okay, okay. Let me finish it. 3 into what? 10 raised to what? Minus 7, the whole divided by, what is the distance? No, my suggestion is instead of putting 0.3, etc., it will be problem for you, man. You have to do squaring it, you may forget the 0.9, like that. So my suggestion is, look into consideration, 3 into 10 raised to minus 2. That's better. 30, how much is it? 30. Whenever you want to change to meter, centimeter to meter, 10 raised to minus 2. Whenever you want to change millimeter to meter, 10 raised to minus 3. Most of the time it will be centimeter. 10 raised to minus 2 is better. And yeah, gram to kilogram, 10 raised to minus 3. Okay, I'll show you that. 13 to 10 raised to minus 2 into 13 to 10 raised to what? Minus 2. Pardon, 1 minute. The whole square, I put it as 10 raised to minus 2 into minus 2. It is easy calculation, man. Look at the calculation, I tell you that. 10 raised to minus 2 and can you see 30, 30? Yes? Can I cancel 10 raised to minus 2 and 2 zeros? Can you do it like that? The 10 raised to minus 2 is minus 1, 30 into 10 squared. Then can I cancel 9 and 3? 3 3s are 9, correct? That's the way to do it. Instead of doing all the multiplication and decimalizing, simple way to do that one. Now you have only numerator only 10 raised to minus 2 is down, you know it? Yes? 2. Yeah. 3 into 10 raised to minus 2. I'll show you one more time if you don't mind. I'll show you, man. See, this is the way to do it. First one is 9 into what? 10 raised to 9, huh? The other one is what? Charge is how much? 2 into next one is 3 into divided by just like a 30 into 10 raised to minus 2 two times, man. Understood? Your wish. The whole square is same as 2 times, you know it. Whole square is same as 2 times, okay? 30 into 10 raised to minus 2, the whole square is 30. Now what I'm saying is that 1 0 1 0 I am saying cancel with this guy, agree? 3 3s are 9, 3 and 3 9, and this 9 will cut off. Now remaining only 10 raised to minus 2, you can cancel with this guy, 10 raised to minus 5 will come. Okay? Now add it. 3 into 2 is 6 or something? 6 into? Yeah, correct. 6 into 10 raised to minus. Don't make the calculation complicated, man. All the time, simplify like simplify. Finished now? All are over? Correctly? The rest do your method of simplification. If you like 0.3, take it as 0.3 into 0.3 comes 0.09, I think, isn't it? Then cancel out, multiply and do that. Denominator is 30 into just multiply like that one. Next is 1.2, please. 1.2. Can you read the question?
The electrostatic force of a small sphere of charge 0.4 microcoulombs due to another small sphere of charge minus 0.8 microcoulombs in air is 0.2 newtons. What is the distance between the two spheres? What is the force on the second sphere due to the first?
Which formula will you apply here also? Can you tell me which formula is good? Identification of the formula is important, please. I gave you the formulas, one of them will work. Yeah, same formula, correct. Oh, my brain, you have brain, I think, huh? That boy, 12C boy, I mean, which class? 12D. Other boys in my class, other of my students, 12D, I think. 12D boys, you have no brain. But you have a little brain, good. Who is the guy you don't like, the 12D boys? Somebody talk about it. You know the guys there? Huh? Austin, not that guy. He doesn't like you, huh? Okay. Yeah. But you have brain, okay? Which brain? Please write the formula according to Mr. Ohm. F is equal to that formula only again. 1 by 4 pi epsilon 0 Q1 Q2 by R squared. Please write the formula again, all of you. F, you can write it as 0.2, I think, isn't it? Point 2 equals 9 into 10 raised to 9 into Q1, Q2 is what? 0.4, huh? 0.4, 0.4 into 10 raised to minus 6, okay. Q2 is also 0.8, huh? Coulomb said only take the magnitude only, don't take the sign, okay? So don't take the minus sign or plus sign, only the magnitude you take it. You know the distance, I think, isn't it? Can you cross multiply that? The 0.2 will come to the denominator, I think, isn't it? Can I simplify the powers of the numerator? 10 raised to minus 6 will be 10 raised to minus 12. Okay. Minus 12 plus 9 is what? Minus 3. Yes. Okay. Let me check it 1 minute. Into 10 raised to minus 3 or plus 3? I said plus 3 or minus 3? Point 4 and point, if you find difficulty, multiply by 10 both sides, it will become 4 by 2, you know. 0.4 into 2 is 4. 0.2 into 10 is 4. So it will be 2 only, isn't it? Numerator. 10. What is the R squared value coming? 144 something, it comes, I think, 9 into, yeah. Therefore, R is equal to 12, I think, 12 into 10 raised to minus 2. So 10 raised to minus 2 meter, isn't it? Yes. Yeah, correct. Simple questions only, not so difficult, okay? Finish all of you? Sure. Please. Can I go to the next question? One point three. Can you read the question, please? Hello. Read the question. 1.3. Read the question. K is squared by. Yeah. Okay. Can you write down 1.3, all of you? Please write down. K, you write the value. K is 1 by 4 pi epsilon naught, you know. That is equal to, you know, that value. Today I gave you 9 into what? 9 into 10 raised to 9. Nm squared C minus 2. nm squared c minus 2. And I remember G, anybody knows what is G value? Last year you learned it. Yeah. G is gravitational constant, you know. Can I write down G is equal to 6 point something, isn't it? 6 point. Yeah. 6.67, I think. Unit here, right? Nm squared kg minus 2, please. Nm squared kg minus 2. Finish. E is charge of electron, you know. E is charge of electron, 1.6 into 10 raised to minus 19. You have to remember this, okay? That is Coulomb. E is 1.6 into 10 raised to minus 19 Coulomb. Finish. Finish. Me is mass of electron, you know. Anybody remember? 9.1. Try to remember it. Minus 31 kg, right? That you have to take it from the tables. They will give in the question paper, okay? They're asking that, okay? All these values they will give in the question paper, front page of the question. Mass of proton, 1.67 into 10 raised to minus 27 kg. Mass of proton is 10 raised to minus 27 kg. Finish up here. You have to prove it is a dimensionless ratio. You have to prove that it is a dimensionless ratio, okay? And on the units of the given ratio is, and on units of given ratio is K E squared by E M E M P. What is the dimension of K? Just now you learned it, Nm squared. Nm, can you check it? Nm squared? C minus 2 into what is the unit of V? C squared. Divided by G value, remember? Nm squared what? Kg. Then mass is MP is kilogram into kilogram. Can you cancel the units? Everything will cancel, I think, isn't it? Hello. N and then okay, everything will cancel. Yeah, C squared C minus 2 will cancel. You can write it as dimensionless, M raised to 0, L raised to 0, T raised to 0. Because nothing is there, it will come as 1 only, you know that? Is it 1 only, correct? C squared and C minus 2 cancels. N and N cancels. M squared cancels. Kg squared and Kg minus 2 cancels, isn't it? So can I write down M raised to 0, L raised to 0, T raised to 0? Then you write, given ratio is dimensionless. Given ratio is what? dimensionless. Given ratio, last step is given ratio is dimensionless. Can I write numerical value? Next subheading, numerical value. Numerical value, 9 into 10 raised to 9 into 1.6 into 10 raised to minus 19, the whole square divided by 6.67 into 10 raised to minus 11 into 9.1 into 10 raised to minus 31 into 1.67 into 10 raised to minus 27. Simply put the values of that. Can I have the last value, please? That will come to 2.4 into 10 raised to 39. You can check at home, okay? 2.4 into 10 raised to 39. Then you write the last step. This is the ratio of, please write fast. This is the ratio of electric force to the gravitational force. This is the ratio of electric force to the gravitational force between a proton and an electron. Repeat one more time. This is the ratio of electric force to the gravitational force between a proton and an electron, keeping distance between them, a constant. Keeping distance between them is a constant. Time over, isn't it? Okay, thank you very much, gentlemen. 12C and 12B and 12C. Very
Thank
small
you, sir.
interaction with you. Yeah, thank you very much. Please tell ma'am we finished up to that, and extra questions, some more are there in the, that she will do it for you. Theory is okay.
Yes, sir.
Versus law important. See you again. Bye-bye. Bye-bye.
Thank you, sir.
Thank you, sir.